Hi guys, this is Saif Jawad, coming back with a new video on reducing code complexity using this time a method of abstraction based on built-in functionality being the HashMap in the Java library itself. So we're going to talk about what we have already covered really quickly, and then we're going to pick up reducing the code complexity using the HashMap with a live demo. This is what we have covered. We did some displacement by responsibility, and we did abstraction by polymorphism, and we also did abstraction by using built-in functionality being the enum the last time. So this is a continuation on the built-in functionality. After showing the HashMap method and strategy in reduction of the code complexity, I would like to take the next movie to pick another topic like framework or functional programming or general code to continue the rest of the strategies that I do use. For now, we're gonna go ahead and start the method of reducing the complexity with a hash map with a live demo. The GitHub repository that it is in is on this screen. I'm going to post the links of the code complexity example with the hash map on the comments and also the solution. Feel free to do the exercise yourself, and if you have improvements, please do not hesitate to send them to me in feedbacks, pull requests, or using comments, whatever you feel comfortable with. I would appreciate all of the input. The recording is going to be used instead of the live coding though, because I have already recorded it. So I might look different with different clothes and different setting, but it's the materials about the hash map that counts. So enjoy. So let's take a look at how to reduce the complexity of this class using a hash map. So what it does is the following. It's a transaction message processing handler. So it gets a message in of different types, like a balance request or a withdrawal request or deposit request or a currency rate request, and then it chooses the corresponding processor for that message. So balance processor, withdrawal, deposit, rate request processor, and so on. Using the if-else method, or in this case a lot of ifs and returns, the complexity is going to grow. And to reduce that complexity and prevent it from growing, you could use a built-in functionality of Java called a hash map. So everybody knows a hash map. If you have done the Java course, then what it does, it couples a value, a key with a value. So if the key is a string, for example, like the name of a class, then you can give it a value being an object of some type. We have already done polymorphism, so there is a bit of polymorphism in here. See, when you have different kind of object and you're returning different kind of objects, then you might have a bit of a problem. I kept it simple for now, and let's see, pull it in, all files are up to date, so it's returning a string. So keeping it simple, so the work that is being done by a processor that is a processor implements an interface called message processor. So we know that a message processor uses the method process to process the message, and it receives a object of the type request message, and the object of the type request message is a request message. For example, a balance request implements the request message, so we know we're always dealing with a request message when it's coming in. That makes our life a bit easier, because now we know what we are going to handle for type or subtype. We do not know, but we know we are getting a request message, and we know we can give a request message to all the processors that accept a request message as input. Having said that, the way to go about this is to create a hash map. So let's say private final a map of the key string and the value of being a message processor. Okay, import map. So our map of key values of string and a message processor is I'm gonna call it message processors. Right. So something we need to do to initialize this value is we are going to do a manual constructor. So public constructor of this class, and it takes all of the previously defined processors. I'm going to do Control R, and they say replace, and go for a comma, another comma, another comma, and one comma less is better. So reformat it with Control Alt R, and then say we don't need this anymore. Now we initialize the message processors. Map, hash map of entries. No, I'm doing it wrong. Is map.of entries. You can also put them whatever, but entries will get you there faster. So entry consistent of map entry. I would like to put it as a static, so we literally have to read less. So what we are going to process is the key would be the request message subtype name. So let's say we are using here a balance request message, and we're gonna get its class and get its canonical name, because that's what we need. And this balance request will have to be processed by the balance processor. So that's entry 1. Let's make a few more entries. Withdrawal, same here. So we'll do the withdrawal, and we'll need the withdrawal request processor. We'll do that as well for the deposit and deposit. And here I'm going to say deposit. If I'm doing anything wrong, just tell me, right? Although it's not interactive, you can send it to me later. And of course, the currency rate request message and the latest processor that we need will be the rate request processor. Having put all of these entries in, now we need to get them out and let them process the information instead of the if-else statements that you see here. So let's do that. Yes, if message is null, then we are going to use the hash map to get the right processor for the message coming in. So we're going to say message processors get message dot class. Oh, I'm doing something wrong. Get class dot get canonical name. So this would be the processor. Final var processors processor. So this is our processor. We have it. I'm gonna do this. If, well, I really don't like ifs. So let's say the processor is if the processor is not null, then return, let's see, return processor dot process message, and we can remove all of these, right? So we are down to a complexity of 7. That's because we have nesting inside. Let's see if I can reduce it a bit more, even though the 7 from 15 to 7, that is also nice, and we can expand the number of entries and the number of messages without ever having to increase this bit of code. So let's do this. First of all, processor, let's do this. Let's do this. Processor is this. If message is processor is message not null, then this, otherwise processor is null. I'm doing it wrong. Let's see, remove this one. I'm focusing too much on cyclomatic complexity at the moment. The problem is actually if we do it this way, yes, there's a ternary operator that decides if we are even going to get a processor or not. But it does help that now we can do this whole thing is gone, and this one too, and we can say processor not null, then process, otherwise return null. So it's the lines of code that we have decreased. The cyclomatic complexity we decreased a little bit, but the cognitive complexity is higher in this case. And personally, I don't like that too much. But for now, I'm gonna let it be what it is. Just showing the functionality of the hash map and well, focus on other techniques, because this is not even the best technique that we can use. This technique I'm using with the hash maps to reduce the complexity, because we are not relying on frameworks. If you rely on frameworks, then you would get even a better a lower complexity score with even more convenient and better to read techniques using polymorphisms and frameworks. But I will do that in the hopefully in the next video. I'm going to combine techniques, so frameworks with the polymorphism, for example, to show you what you can do. So for now, this is a nice result. Let's see if everything runs, if everything goes smoothly. Everything does. You can find the solution just like the code itself on my comments and in my GitHub. I will post these as well at the page. For now, I hope this shows you a different way of decreasing the complexity with a more expandable way. Now we can add as many messages and as many processors as we want, and it will not affect our complexity where it is being processed. We just add new entries to the hash map, which reduces the if-else statements that you saw before. I hope this is helpful, and have fun reducing the complexity of your code. Bye bye.